Today we are getting into our circles unit formally with our first lesson. Yesterday we did demonstrate that indeed the earth is round. So again, these calculations we made here yesterday showing what the radius of the earth is based off this old experiment. You know, we showed how we can apply what we're going to get into with circles before we officially get into the unit. So we're going to learn about central angles, inscribed angles, tangent lines, all sorts of different parts of circles that can really show us a lot about them. So simply put, a circle is a set of all points on a plane that are equidistant from the point called the center. So when we're talking about a circle, you have your center point, and then every point is the same distance away from it. A very simple way to think about this is if you have like a little tether for a pet or something like that. So like if I put a stake in the ground, then put a leash attached to that, then attach that to like a dog or something, a dog can only go out so far, the length of the leash. If they just kept it at the maximum tension essentially and walked around, they would create a circle. So the distance from a point on the circle to the center of a circle. So anybody remember what that's called if I go to the center to the edge of the circle? Yes. So if I go from the center to the edge of the circle, that's the radius. Yep, you got it. So that is the radius of the circle. So a circle is always named by its center. So if I want to talk about this circle here, what point's at the center of this circle? That will be point A, right? Now it's a little hard to read on the smartboard again. The blank notes are there if you want to read a little easier on your screen. So what's the name of this circle? This would be circle A. The line segments E to C and E to B contain 2 points of this. Okay, yep. So, sorry, it was a little light to read here. I know it's not the easiest to read. Again, that's why then we'll go into Zoom or just use the PDF in front of you. So, 2 point, any line that connects 2 points is called a chord. So both going from E to C and E to B, that's called a chord. That's just any line that goes from the edge of the circle to the edge of the circle. Now, E to B is a very special one because it goes through the center. What do we call a line that goes through the center of the circle? Diameter, perfect. Yep. So the diameter goes from edge to edge and crosses the center. We know the diameter is always twice as long as the radius because the radius goes from the center to the edge. So if I go edge to edge with the center, it's basically putting 2 radii together. Now look at this picture. This line segment MP is called a secant. So we said when something stops on the edges, that's a chord. What's happening a little different here? What's special about this line MP? What do you notice about it? Let's look at MP compared to EC. Where does EC start and stop? It stops on the edge of the circle. Where does MP stop? Outside the circle. So a secant and a chord are very similar. The difference between them is a chord is inside the circle, where a secant, or chord, goes through the circle. So a secant and a chord are very similar. A secant just extends outside the circle. So let's take a look now. Over here, they're calling this a tangent. What do you notice is happening with this line here and this circle? What seems special about the tangent and the circle? Secant just went straight through it. But this tangent, what does it do? Yeah, it just kind of brushes the circle, it just touches the circle. It's all the way basically outside except for this point it touches, right? So that's what it means to be tangent. It's just a point that just touches it. So the line passes through X is called the tangent of a circle. So the tangent just touches the circle, where the secant goes through it. X is called the point of tangency because that's where the tangent touches the circle. So X is a point of tangency because X is where the tangent touches the circle. Now, I know some of this vocabulary was very familiar to you. I know some of this vocabulary was a little newer. Are there any terms right now? Now, run through those terms that we need clarification on. So our terms are the radius of the circle. Radius goes center to the edge. We have diameter. That goes edge to edge, passing through the center. Remember, diameter has to pass through the center. Diameter is twice the radius. A chord is just any line that goes edge to edge in a circle. It does not have to pass through the center. A secant is a line that extends outside the circle but cuts through it. And a tangent is this special line that just kind of quickly touches the circle, but doesn't actually go through it. So, thank you, Logan. So, Don, Kelly, Susie, and Paul are enjoying a ride on this Ferris wheel. You can see their locations right over here. Thank you very much. So we're going to draw an angle with the center on the Ferris wheel as the vertex, and Don and Kelly are located on the sides of the angle. This is a central angle, so I'm going to draw this in right here. Why do you think we call this a central angle? Because yes, the vertex is in the middle of the circle. That's what a central angle is. So it is, why is it a central angle? Because the vertex, which is the turning point of the angle, is located at the center of the circle. And if we think back to what we did, not circles, what we talked about yesterday, about the earth being round. Now, my drawing was really bad over here, but this was a central angle. I went to the center of it to find the radius. So again, that vocab kind of reappearing here. Okay, now the next one's a little tougher to figure out why we call it that. Now it says draw an angle with Susie as the vertex, and then I'm going to go from Don to Paul after visiting Susie. This is what we call an inscribed angle. Where's the vertex located on this inscribed angle? Is it at the center? It's the edge of the circle. So an inscribed angle has the vertex on the edge of the circle. So why is this an inscribed angle? Because the vertex is on the, I like how you added the word edge in there. I'm going to include that as well, on the edge of the circle. So looking at these two angles, we have that central angle in blue, or sorry, central angle in red, inscribed angle in blue. What do you notice is similar between them? Any similarities between these angles? I notice they're both inside the circle, right? But their vertexes are located at different places, right? So what do they have in common? What do they have in different? So both are inside the circle. What do you notice is different about them? Some differences between the arc they relate to and the angle, but we'll get into that next week. The big difference I want us to take away right now is central angles have a vertex at the center but inscribed have it on the edge. Okay. So now here, if I were to make something like going from E to B right here, that is an unbroken portion of the circle between 2 points on it. Does anybody remember the vocab word to describe going E to B on the edge of the circle? Going E to B, does anybody remember that? Let's start with an A. It is called an arc. So an arc is just that fraction of a circle. So now what it said it wanted us to trace going from D to B. This is what we call a minor arc. We'll talk about that in a second though. But let's see here. If I go like this, go from D to E, how will we describe what I just did in blue? There's a special word when it's half the circle. Semicircle, there we go. So a semicircle, I spelled the word circle right, sorry about that, is the arc that is between 2 points of the diameter. Locate the diameter and trace them. So how do we name an arc? So here I went from D to E, right? But I could go D to E this way or this way. What I'm going to do is, because I went D through F to E, I'm going to call that arc D, F, E. I put a little arc symbol above it. So if I'm more than half a circle, I'm going to call that a major arc. If I'm less than half a circle, that will be a minor arc. And that's it for our vocabulary. Any questions right now on this? So, quick rundown this back page. So we are going to be looking at 2 types of angles inside of a circle. There's a central angle where the angle's at the center, and the inscribed angle where the angle is, or the vertex is on the edge of the circle. Both central angles and inscribed angles will create arcs. We're going to learn the relationship between the arc and the angle in just a little bit. But for today, we just need to know that vocabulary. So remember, an arc, if it's less than half the circle, we call that a minor arc. If it's more than half a circle, it is a major arc. And remember, half a circle is called a semicircle. So that is what I have for you today. Let me stop recording. Yes.